Hi, I'm Andy Gearing. This is Greg Dickson and David Zordich. And we are web developers, but we are also gamers. And we decided that the most exciting way for us to showcase our skill is by making you this game, 0 Hour. This is a game from a top-down perspective. It's a science fiction shooter. The player holds off hordes of zombies, and there are survivors that run across the bottom here, increasing the player's score. This project was so fun. We got to learn object-oriented JavaScript through a tool called Phaser. We got to learn how to animate. We got to deal with assets on a scale we had never done before, with music and art. We got to learn about asynchronous programming and the challenges that come with that. When the documentation fell short, we dug into the source code, and when we couldn't find the right tool, we made our own. Passion was a big deal for us too, as you'll see very soon. We had a lot of passionate disagreements internally. We had to manage that, and we were always pulling forward. But more than that, when we made a game, we knew that it was going to be easy to compare us with much larger teams that had a lot longer to make a game. We knew that going in, and we really embraced that challenge. And the secret sauce for us was testing. From day one, it was baked in. We tested very aggressively. Every time we added a feature, we tested it extensively. We deployed as early as we possibly could, and we invited our friends and family to give us feedback, which gave us a lot of great features, and also some really interesting bugs, as Greg's going to tell you.
Thank you, Andy. Yeah, the black box bug. This was an interesting one. So what made this so difficult is that none of us were experiencing this error locally, but when we sent the beta testing link out to our friends and family, they were like, hey, cool game, it's awesome, but what is this giant black box that's snarling at me? So through a lot of testing and research and using our testers, we were able to identify that we needed to cut the source image in half and then double its scale in order for it to render with the rest of the images, because it was larger than most of the images on the screen. So a software that we had to learn that was brand new to us was a software called Tiled. Down here in the corner, we would have to load the assets, and then each one of these assets had to be placed individually. And what made this a challenge is that not all of the assets are mathematically structured the same. So there's a lot of math that you had to do in order to size and resize the individual tiles so that when you piece them together, it makes one giant image without a bunch of white space. Up at the top here, you're going to see our character sprite sheets. When we first started out, we used a lower resolution, and so we were able to use Painter, and we would just cut and paste individual directions for different sprites to make one giant sprite movement. When we moved to a higher resolution, this wasn't possible to do by hand. So we got together and we actually created a program ourselves in Python that would create and cut these sprite sheets for us. Another thing that we were proud of is the fact that we're running 2 simultaneous front ends in order to get a high resolution HUD and a darkness effect. And that's what gives kind of the shadow when you play. David?
So one of the greatest challenges for us is that gamers demand high performance out of their games. Now, in none of our projects at Momentum did we have to worry about optimizing for performance. In an early build of the game, the lag was so bad that you basically couldn't play past round 4. However, we were able to research and learn best practices for optimizing performance and managing memory, refactor our code, and implement what we had learned successfully so that we could run our game stably and smoothly as far as we could play it with no input lag and no drop in frame rate. This is a game changer for us. As you can see here, we're on round 12, smooth as silk. Another challenge that we face is that gamers expect the characters they do not control to still move and behave in a realistic manner. This meant that we had to implement quite a few rather exotic algorithms to govern the behavior of the zombies. Even behaviors as simple as getting the zombie to face towards the player, like you see here, were surprisingly complex. For example, the code to get the zombie to face towards the player, it's pretty self-explanatory, I think. I don't want to spend too much time on it. At the end of the day, our harshest critics were ourselves. And we are truly, deeply proud to show what we've created. So proud, in fact, that we want to give each and every one of you a chance to play our game. So, we'll have a couple computers back in our booth running the game. You're all welcome to come out, give it a shot. There'll be a prize for whoever gets first place by the end of the night. Anyways, thank you all very much. We hope you have half as much fun playing the game as we did making it. Good night.